So we start here, okay? This is the big idea today, okay? And once we can do this, the rest of it's quite easy. We have the log base 8 of 400. What that means from what we learned yesterday is it means 8 to what power is equal to 400? Somebody make a guess. I've got 4 out there. We'll try that. Turn my calculator on, and I go 8 raised to the 4th power. We get 4,096. Okay, so 8 raised to the 2nd, so that's not right. Somebody else. 8 raised to the 3rd, that's too much, right? So everybody agree it's somewhere between 2 and 3. So you're trying 2.6, 8 raised to the 2.6. Into 2.8. Into the 2.93. 2.91. Into the 2.9. Would it be nice if we had an easier way to figure this out? Here's how we do it. If you want to find the log base b of something, what you do is take the log of the top, or log of the x, divided by the log of the base. So here's what you do. You want to know what log base 8 of 400 is? You want to know what that number is? 8 to what power is 400? You do log of 400 divided by log of 8. Now, look at what happened. And this is, you don't ever have to actually do this. You just have to acknowledge it, okay? The base here is 8, isn't it? What's the base in our new formula? 10. And so I take out my calculator and I go like this. I turn on, you guys know it's around 2.9, correct? I take the log of 400 and I divide it by the log of 8. And I do that and I get 2.88. So we'll try that number. 8 raised to the 2.8812. And what do I get? I get 399 point, yeah, pretty close 400, right? In order for it to be accurate, you actually have to carry out to at least 6 decimals. That's the way exponentials work. So here's this piece. So we have, I want you to estimate this. 6 to what power is 14? That's what that means. So it's going to be between what two numbers? It's going to be between 1 and 2. Yeah. So I do log of what? 14 divided by log of 6. I take out my calculator. Log of 14 divided by log of 6. And I get, there you go, between 1 and 2, it's 1.472. We'll just go to 3 decimal points. Using your phone or your calculator, whatever you have, see if you can come up with the decimals for B and C. Since we're not all using TIs, I want you to use whatever device you have to see if you can come up with the right decimals for B and C. Go. If you leave your calculator in here, you might want to try like that black square box back over there. But I do just want to warn you that I do not take any responsibility for anything you leave in here. So there are cameras right outside my room, but you know, who knows? Okay. I'm ready to teach you guys a really, really big and important idea. And it's not difficult, but it's totally new understanding, okay? Log base 4, 4 to the 5th. What we said yesterday is that means 4 to what power is 4 to the 5th? What goes in place of the question mark? 5. Does everybody agree? Log base 8 of 8 squared. That means 8 to what power is 8 squared? Log base 9 of 9 to the 1. That means 9 to what power is 9 to the 1? Everybody agree this is 5? Here's the amazing thing that happens, folks. I know this sounds ridiculous, and you're going to hate it when I do this, but just Trust me that the mathematics is correct, and I will show you why. Log base 4 and 4, they are what we call inverse operations. They cancel each other out. You're left with 5. These cancel each other out. You're left with 2. These cancel each other out. You're left with 1. These cancel each other out. You're left with 5. Now, I know that that seems absolutely ridiculous, but there was a time. Now, Tenley, my little, 9-year-old, she's gonna be 9 here really soon. If she's doing some algebra someday and she wants to solve x plus 3 is 8, what should she do to both sides? She should subtract 3 because we say that those are inverse operations, right? Adding 3 and subtracting 3, they undo each other. Now you're like, well, that's easy, Mr. Gens. Well, once upon a time, we told you that x squared was 25, and how did you undo that? You did that, right? I mean, that looks a little crazier than that, right? Well, now I'm telling you this. Log base b of b to the x, these guys are inverse operations. They undo each other, kind of like a square root undoes a square. They make each other go away. It's a beautiful thing with logarithms, and it's why they're so important. They allow us to solve exponentials. So log base a of a to the x, these are going to cancel and just leave you with x. So why is that cool? Because it allows us to solve this. 8 to the x is 162. I want to get to the x, so I'm going to get rid of the 8. Watch what I'm going to do. I'm going to take the log base 8 of both sides. Look at what I did. All I did is I put a log base 8 on both sides. What you do to one side of the equation, you can do to the other, right? What happens on the left side? It just goes to x. Did we learn how to find out log base 8 of 162? We just learned that at the beginning of class. How do we calculate that? What do we do? Log of 162 divided by the log of 8. And I can figure that out. I go to my calculator. I do the log of 162. I divide it by the log of 8. And I get 2.44. We'll go to 3 decimal places. 2.446. If I take 8 and I raise it to the 2.446, I should come out with a number close to 162. And do I? Yeah. I'm going to do one more with you, then you're going to try 2 on your own. We won't get to the back side notes today, but we will finish off the front. I want to get to the x. What do I have to get rid of in order to get to the x? 17. So I take log base 17 of both sides. That's how I get rid of a base 17. You don't divide by 17. That's if it's 17 times. This is 17 to the. So what happens to the left side? The left side. It cancels out, leaving me with x. On the right side, how do I do log base 17 of 64? Log of 64 divided by log of 17. Log 64 divided by log 17. And I get 1.468. I want you to try letter D and letter E on your own. Try right now, see if you can solve it. Please make sure you write out the log on both sides. Go ahead. Do you remember what we write if the base is E? We take the natural log of both sides. So natural log has a base of E. And natural log causes this to cancel out. Natural log and E cancel each other out. What are you left with on the left-hand side? x equals. Now here's the cool thing, folks. You got natural logarithm of 2. Look at your calculator. You have this button right here. Just press natural logarithm of 2. See? I bet you got natural logarithm on your phone. See that? Yeah. Oh my gosh. There's just. Yeah. Look at this one. I want to get rid of the e. How do I get rid of e? What do I do to both sides? I take the natural log of both sides. What do I remain on? What remains on the left-hand side? X. And on the right-hand side, I don't have to use a change of base. I could just simply press natural log of 25. And I get 3.218. Did you learn something new today? It's not that bad either, is it? Okay. So tomorrow we'll practice with it and we'll give you a worksheet. We'll do some warm-up pieces. And we'll try a couple on the back there, just a little bit more involved. The back, all we have to do is just, well, you end up having to subtract 3 and divide by 2. So you totally do it.